the last section here in chapter 9 that we've talked about, and we're going to talk about angles of elevation and depression. Angles of depression, the angle down from the horizontal line of sight. So what we're looking at here is we have our horizontal here. We have our line of sight. And our angle of depression is the angle between there. Okay, so that's what an angle of depression is. Angle of elevation, the angle from the horizontal up to the line of sight. So here is our horizontal. And here's our line of sight. So when we look, angle of elevation is looking up to that line of sight. Now, when we do these, something to keep in mind, that if we were to take this and just connect this horizontal going across, and here we would create a rectangle where those two sides are equal to each other and parallel. Those two sides are equal to each other and parallel. And this angle would also be equal to that angle. Now, why does that come in handy? Because that way then you can go through, depending on what they give you, and rotate or translate those values around to make an easy right triangle where we can use our trigonometry to solve. Okay, so let's try one. It says, an inquisitive math student standing 25 feet from the base of the Washington Monument. So here is our Washington Monument. And then 25 feet away, we have our student. And they are looking up at the top, and it is the angle of elevation from her horizontal line of sight is 87.4 degrees. And it says if our eye height is 5 feet, okay, then how tall is the monument? So when we do this, we're going to have to make sure we take into account that 5 feet. So where does that 5 feet lead us? So the first thing I'm going to do is I look at my ratio, and here's what I have. I have an angle. I'm looking for that side, and I have that side, which we should be able to recognize hopefully by now that that is a tangent relationship. So we have tangent of 87.4 is equal to opposite, which is x, over the adjacent, which is 25. We're going to multiply both sides by 25. So we end up with 25 times the tangent of 87.4. And that is approximately, so we take our calculator, tangent 87.4, and we end up with 550.5 feet. But now we have to take into that 5 feet, so we're going to add that 5 feet on, which gives us a final approximate answer of 555.5 feet tall. Okay, so as you notice, these are very similar to what we have been doing. It's just a matter of setting up your triangle correctly. Okay, let's try another one. An eagle perched 40 feet up in a tree. So we have this tree, and we have our eagle. Okay, and they are perched 40 feet up. And down at a 35-degree angle of depression. So what that means is this angle here is going to be the 35. Okay, and over here we have this little vol. All right, that's good enough drawing. So now we want to find, it says, how far is the vol from the eagle to the nearest tenth, which would be this value here. So we actually have a choice here. We can either translate this over, or we could take the 35 and translate it down. Either way, we get the exact same thing. So now I look, and I have, what I'm given is I've got an angle, I've got the opposite and the hypotenuse. So that is going to give me the sine of 35 degrees is equal to the opposite over x. We'd multiply both sides by x. and then we would divide by the sine. And when we do that, we end up with 40 divide sine of 35. And that's going to give us 69.7 feet is how far the eagle is from the vole. Okay, so like I said, this is very similar to what we have been doing. It's just a matter of now putting it in the correct representation in the triangle. And that is angle of elevation and angle of depression.